Okay, I'm going to do a couple more really very hard ones. So let's look at this. Does not look simple with all of these complicated exponents. Okay, so there's another strategy, which is to factor something out. Let me just go back to if we had something like this, 3x cubed plus, I don't know, 2x squared plus x equals 0. We could just factor that x out, x squared plus 2x plus 1. I don't think I made up one that factors, but anyway, okay, what's happening when I just say, hey, just factor it out? What I'm doing is actually dividing each of those terms by x, and the only way I get to do that is if I also multiply everything by x. Because we can't just change it. It started with an x cubed, right? So what we end up with needs to be equivalent. So if I have my x out here and I multiply it across, it would bring me back to what was originally there, which is x cubed, okay? So factoring out, what that really means is dividing by the lowest term that's there, okay? So I'm going to use that strategy for this harder problem. Okay, I'm going to look to see. I'm going to go ahead and erase all that. Okay, let's look at C, who is our lowest x. Okay, and it looks like 1/2 is the smallest number that's up in all of those exponents. Okay, so I'm going to factor out an x plus 1 to the 1/2. Okay, just like we did here. Out came the x, right? And what that really meant is I was dividing each thing by that term. Okay, so I'm going to also divide by x plus 1. Oh, it's going to be a little too messy. Okay, sorry, I'm going to just do it down here so we can see what's happening. Okay, so I'm just going to make this nice and big. So out comes the x plus 1, 1/2. Okay, so I'm going to factor out that term and divide everything by x plus 1 to the 1/2. X plus 1 to the 3/2 divided by what I'm factoring out, and x plus 1 to the 5/2 divided by what I'm factoring out. Okay, so now here, back, I'm just bringing this back to what we actually know how to do. What did I do? I said I got 3x squared and 2x. But that's because this x from down in the denominator canceled with 1 on the top. What you're really doing is subtracting your exponents, okay? So I'm subtracting exponents there. Subtracting exponents. Okay, so out came my x plus 1 to the 1/2, okay? And so then that's being multiplied by 2 times x plus 1 to the 0. What is anything to the 0? Give you a second to think while I erase. Anything to the 0 is, that's just 1. Okay. Now, 3 times x plus 1, 3/2 minus 1/2, that's 2/2, which is just 1. And then we have x plus 1, 5/2 minus 1/2, that'd be 4/2. Which simplifies down to 2. Okay, here, taking something to the 1/2, that's the same thing as taking the square root of it. This is just 2 times 1, so that's 2. I'm going to distribute my 3. We don't even need this 1 there. So I'd have minus 3x minus 3, and then x plus 1 squared, that's x squared plus 2x plus 1. Okay, so I'm going to have that as well, x squared plus 2x plus 1. Wow, okay, let's see if we can simplify in here. This is still x square root of x plus 1. I'm going to write my x squared first. Okay, now I'm going to look for any x's that I might have. A negative 3x minus 2x. That would give me minus x. And now let's collect up all our numbers. 2, Minus 3, that's minus 1, plus 1, that's just adds up to 0. So my numbers add up to 0. Okay, this looks way better already. Okay, let's go ahead and factor out our x here. Okay, so I have square root of x plus 1 times the x that I factored out, and then I'm left with x minus 1. Right, out comes my x. I'm dividing everything by x. And now I get to use my zero product property. That tells me that either the square root of x plus 1 is equal to 0, or x equals 0, or maybe x minus 1 equals 0. Okay, squaring both sides here, I would get x plus 1 equals 0, so x equals negative 1, x equals 0, and x equals 1. We do want to just double check back in our original, because sometimes the negatives don't work, especially if we're taking the square root of something, but because it's x plus 1, if I plugged in a negative 1 there, it's not going to be me trying to take a square root of something negative. It's just 2 times 0, your square root of 0. So that will work. That would be just 0. All these are going to be 0. Minus 3 times 0 plus 0 equals 0. So that one works, and actually all of them work if you go in and plug those in. Okay, so if it looks like substitution, like the problem is just more complicated than substitution can handle, try factoring. Okay, I'm gonna show you one more. Scoot up. Okay, this one certainly is complicated. I don't want to try substitution. It's just a big mess with all those negatives. Okay, so I'm going to try and factor. What I do when I factor is I find the smallest exponent and I divide everything by that. So x to the negative 3 halves. You don't have to worry about the 16. We'll just let that be. It's just the x to the negative 3 halves. Okay, but I can't just randomly come in and start dividing by an exponent or dividing by an x. I also have to multiply. Shouldn't we just set it equal to 0 first? Let's do that. Okay. Okay, so I just moved my 16x to the negative 3 halves over by subtracting it from both sides. Okay, so now I am going to take that smallest exponent, that's what I'm going to factor out. So x to the negative 3 halves factors out, and I divide everything by x to the negative 3 halves. Okay, excellent. And when you have exponents where there's division, you get to subtract the denominator. So I'm subtracting a negative 3 halves, subtracting a negative 3 halves, minus negative 3 halves. So we get negative exponent here means it's the reciprocal to the positive power. And then here I would get x to the 1/2 minus negative 3 halves means I'm adding. So it'd be 1/2 plus 3 halves. That's 4 halves, which is 2. And then I have, let's see, x to the negative 1/2 plus 3 halves. That would be 2 halves. So that's just 6 times x. And then minus a negative, these would just go to negative 3 halves plus 3 halves. So that would be x to the 0, which is just 1. So that ends up just being minus 16. And then we use our zero product property. So we have either 1 over x to the 3 halves is equal to 0, or, so I'll go ahead and factor that. Oops. Let's see, so that would be x, how about we do 8 and 2. So that would give us x plus 8 is equal to 0, or x minus 2 is equal to 0. And then we'll go through and solve and check. All right, here we have something to the 3/2, so I could take everything to the reciprocal power on both sides. So I'd get 1 over x is equal to 0. And that doesn't work. I always kind of think money here. If I have $1 and I split it with, no matter how many people I have, I still have something to give them, even if it's just a little micro tiny piece of dust of $1. Okay, so this one has no solution. So that means that 1 over x to the 3/2 is not going to be a solution. Okay, let's try this one. We would have x equals -8. But when we go in and check this, it doesn't end up working because we have x to the 1/2 plus 6x to the -1/2 equals 16x to the -3/2. These are a 1/2, that's a square root. So if I'm trying to take the square root of a negative number, it doesn't work. No real solution. So that one does not work. This one doesn't work. The other one ends up working. So x equals 2. That one does work. So that's our solution. And the check is kind of fun, a little tedious, but anyway, it will end up checking out if you feel like spending the time doing that, as if you don't have 100 other things to do with all your other classes. Okay, but that's kind of the big idea with those ones. When they really look like nothing's going to work, try this factoring technique.